In this video, we'll look at different approaches for accessing and permuting data in ND arrays. So by the end of this video, you should be able to use slice indexing to access subsets of an ND array and recognize that using such indexing creates a second reference to the same underlying data. From strings and lists, we learned that we could use slice indexing to get subsets of those data structures. We can use similar indexing to pull out subregions from ND arrays. Again, we'll import Numpy as NP, and we'll create the same 3x4 ND array to work with for a few of our examples. Notice that to help us show you how these work, we filled in the values in the matrix with numbers corresponding to the row and column. For example, row 1, column 1 is 1, 1. This should help us keep track of which values correspond to what. We'll next use slice indexing to pull out the first two rows, rows 0 and 1, and then we'll grab the middle columns 1 and 2. When I run this, I expect to get back a 2x2 matrix. Let's take a deeper look at how that just worked. Here's the composition of an array. We've got 3 rows and 4 columns. Now we ask for a slice of that array. For the rows, we ask for all the rows before row 2, which gives us back 0 and 1. For the columns, we ask for columns 1 through 3 with 1 inclusive and 3 exclusive. This corresponds to columns 1 and 2. So when we print the contents of a slice, we get back just the region in yellow here. A slice is pointing to the same elements in memory as an array, which is why I'm referring to a slice as part of an array. Zooming in a bit, this is part of an array pointed to by this a slice. What's both convenient and also sometimes confusing is that a slice has its own indices, and these indices are different than the indices in an array. This becomes clear when we try to access an element in a slice. If I ask for a slice 0, 0, that's the element with the value 12. It's the same element as 0, 1 in an array. This might seem a bit confusing, that you'd access the slice based on its own 2x2 indices, but that's actually exactly what you want. You want to be able to treat a slice as a 2x2 matrix without any worries about where in some larger data structure those elements might be. Next, let's go back to the notebook and see how changing element 12 using a slice actually changes the contents of both a slice and an array. Here I'll print an array 0, 1, which is the element 12 that we just showed in the diagram. Then I'll change the corresponding element in a slice, which is at 0, 0 to 1000. When I look at an array 0, 1, we should see that it has been changed as well. And it has. The reason I spend so much time pointing this out is that it's really easy to forget that slices are just references to the same underlying data as the original array. If you wanted to have a slice be a copy, you have to make these changes. First, let me run this again. And then, instead of just asking for the slice of an array, I'd have to essentially make a copy. And to do that, I'm going to type np.array and then feed in this slice. That will create a copy of that portion of np array and give that to a slice. So now when I run this next block, we're going to find that even though I changed a slice, I didn't actually change the underlying code. And this was because I made a slice to be a copy. So let's see a few more examples of slicing, but I'll move a bit more quickly now that we've done one example in detail. First, I'll create that same array, an array. I'll hit run. Now I'll use an index, just a single index for the row, and a slice for the column. By putting a colon, it means all columns. So here I'm asking for all columns of row 1, and I should get back 21, 22, 23, and 24. The interesting part here is looking at the shape. Because I've used a single index to access the row, I actually get back a rank 1 array, which I could index with a single number. Using the single index is a special case, because if I use slices to produce a 1x4 array, it will still be rank 2. Let's do that. row rank 2 is being assigned just row 1 using slicing in all the columns. When I ask for that array and its rank, I'm going to get back that's a 2D array. Notice the double brackets at the start and the end. And this is shown by the fact that this is a 1x4 rank 2 matrix, not rank 1. Here we'll do the same thing for the columns of the array. We'll grab column 1, which has elements 12, 22, and 32, using the index for column rank 1. We get back a rank 1 array with those values, but using the slice indexing with col rank 2 gives us back a 3x1 rank 2 array. Sometimes we like to use arrays of indexes to access or permute our larger matrix. Let's do this in the following example. First, I'll create a 4x3 array. Next, I'm going to create an array of indices with the values 0, 1, 2, and 0. I'll also use the npRange function to create an indi array with the values 0, 1, 2, and 3. Let's quickly examine how these values might pair up if I use them as row and column indices. I'll do that with a quick for loop and the zip function. We get back that the corresponding 2D indices would be 0, 0, 1, 1, 2, 2, and 3, 0. If you're curious about how that zip function works, you can always go back to our earlier lessons on Python. Okay, now let's inspect the contents at those pairs of indices, and we'll get back the values 11, 22, 33, and 41. This is pretty useful. We can access elements using arrays as indices. We can also change elements in the array the same way. Here, I'm going to add 100,000 to an array for our row and column indices. After inspecting the array, we see that 0, 0, 1, 1, 2, 2, and 3, 0 have all been incremented. Keep this trick in mind for later in the course when we start doing data cleaning. Slice and array indexing is at the heart of Numpy and is both really convenient and extremely fast. There's one other form of indexing which we need to learn, and that requires us using conditionals based on the values in the indi array. We'll do that in our next video.